Hello and welcome everyone. We're happy that we're all together again. In this tutorial, we'll start discussing the different types of the lamps. So fasten your pull and let's get started. The aim of this tutorial is to take a quick overview on the different main categories of the lamps that are used in the lighting system design. And then we will learn the required details about the filament lamps that will help us for implementing any lighting system design. So let's go ahead. First of all, we can categorize the different types of the lamps into three main categories: the filament lamps, and the gas discharge lamps, and the LED lamps. And this categorizing process is made according to the working principle of each type of them. And that means the filament lamps have the same working principle, and the gas discharge lamps have the same working principle also, and also the LED lamps works with the same principle. So according to the method of operation, we have those three main categories. And for that, let's see what is the working principle of each of them. Here for the filament lamps, there is a conducting material inside the glass bulb, like that one here, that is called the filament material, and this filament material is made of the tungsten in many cases. And it produces the light by the way that it enables the electric current to move through the conducting material, that is the filament material. So when the electric current is moving through it, its temperature starts to raise up, and when its temperature raises up, it produces a kind of light and another kind of heat. So that's the basic idea about the filament lamps. After that, we have the gas discharge lamps. That is another kind of the lamps that has a gas inside it, like the helium gas for example. And when an electric power source is applied to that lamp, the gas inside it starts to gain some energy due to the increased electrical voltage that is applied to the lamp, so the voltage makes the molecules to gain energy. And then those gas molecules starts to accelerate and collapses with the glass bulb, and due to this collapsing operation of the gas atoms or molecules, it starts to light up to produce the required light. So this is for the gas discharge lamps very simply. And finally we have the LED lamps. So they are a new technology of the lamps that uses the semiconducting material to produce the required light, as the LED or the LED is the abbreviation of light emitting diodes. So that means the LED lamps is nothing but a special kind of the diodes that are used to produce the required light. So it's a diode consisting of two terminals, the anode and the cathode. And then the electric current is moving through a specific direction from the anode to the cathode, and then the electric current is moving through a specific direction from the anode to the cathode, and at that condition the lamp starts to light up with a specific color according to the wavelengths of the produced light. But you know, for the shape of the market LED lamps that we will use in the interior or the exterior design, it looks like that one or that one here. So that lamp consists of many small LEDs, that is the accumulation of all of the LEDs generating the required light with the required amount of lumens according to the manufacturing specifications of the lamp. So that's about the basic idea about the LED lamps. And now we need to start with some details about the filament lamps to understand the required details related to it. As we said, the filament lamps consisting of a conducting material, and when there is an electric current that is moving through it, its temperature starts to rise up to increase greatly, and for that it produces the required light. But this filament material itself must have some specific properties to do its job well. So the first property of the filament lamp is that it must be made of a material that is capable of increasing its temperature highly, like the tungsten material, and the aim of that is to produce the required light. As when its temperature increases, the lamp produces a larger light. And the second property of the filament material depends on the first one. As we said, its temperature increases highly, so it must be made of a material that is able to withstand the larger amount of temperature that is produced from it. As some other metals melt when its temperature increases highly, so that filament that is made of the tungsten can withstand a larger amount of heat without melting up. And also the third property of the filament material is that it has a higher value of resistance. So this is to decrease the electric current that is going through it, and we need the electric current to be smaller for the lamp to limit its electric current moving through it, so we can limit the absorbed power when the current decreases. And we achieved that smaller current from that relation here, so the current equal the voltage over the resistance. So when the resistance increases, the current will decrease as a reason of the inverse relation between the current and the resistance. Very good, so that's about the filament properties. But we need now to talk about the lamp properties itself. So what are the properties of the filament lamps as a whole? Here, the first property is that the lamp produces a larger amount of heat out of it. As we mentioned, the filament temperature increases highly. But this is a big disadvantage of the lamp, as when it produces a larger heat, this means that a larger amount of electric power is converted to heat. And for that, the second property is that the lumens out of that lamp is low compared to the electric power that it consumes. So it produces a lower value of lumens. And the third property is that it has a larger total losses, and this is due to the excessive heat that is produced out of it. And then the fourth property is that it consumes a larger power. And finally, a logical result of those first four properties is that it has a lower efficacy, as the efficacy equals the lumens over the power as we learned before. So when the lumens are small and the total electric power is large, we will find that this is because the lumens is low and the heat emitted from the lamp is high. So all of those properties will produce a lower overall efficacy, as you see. Alright. So that's about this tutorial, and on the next tutorial we will extend talking about the filament lamps. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. We're happy that we are all together again. In the previous tutorial we ended with the filament lamps by discussing its superpowers, and now in this tutorial we will continue illustrating some important aspects related to the filament lamp. So fasten your belt and let's get started. The aim of this tutorial is to continue understanding the different purposes of the filament lamps, and also we will discuss its applications or its use in the indoor lighting system design. And finally, we will understand what is the different kinds of the filament lamps. So let's go ahead. The next important property of the filament lamp is that it has a lower lifetime that has an average value of 1000 hours. And this means the filament lamps works with an average number of hours of about 1000 hours, and after that it burns out or damaged. But this is a very low number of working hours compared to the other types of the lamps that lasts more than 1000 hours. So in general, this is a low lifetime for the filament lamps. Also, the seventh property of the filament lamp is that its light output can be controlled, and this means that we can vary the output lumens out of the filament lamps, and this is a big advantage of the filament lamp, as it's the only lamp that we can control its amount of light that is going out of it. So we can control the amount of lumens out of the filament lamp, and this is by a switch that is called the dimmer switch. So by changing the selector of the dimmer switch, we can control the light out of it. And we can control the light output of the filament lamp basically because the filament lamp consists of a constant resistance, which is the filament resistance. And because the electric current equals the voltage over the resistance, so when the resistance is constant, this means that the electric current has a direct relation with the voltage. So by controlling the dimmer slider, we are controlling the input voltage of the lamp. So when the voltage increases, the electric current will increase, and when the current increases, the light output of the lamp will be larger, so it will produce a larger lumens. Also, the inverse is right, as when the input voltage decreases by controlling the dimmer switch slider, so the input current at that condition will decrease, and then the light output of the lamp or the lumens output of the filament lamp will decrease. Very good. Also, the last property of the filament lamp is that it has a very high value of the color rendering index that reaches about 0.97. And this higher value of the CRI makes it to be the best type of the lamps to show true vision of different colors, as the higher color rendering index enables the lamp to express the object's colors in a true vision with compared to the colors that are seen in the sunlight. Alright. Now let's move to the applications of the filament lamps, and those application depends on the nature of the filament lamp itself or its properties. So if there is a specific application that needs a specific property that exists in the filament lamp, at that case we will use the filament lamp in that application. So the filament lamps are used mainly in three different applications. The first one is the decoration purposes, and this is due to the decorative style of some filament lamps, so it gives the interior design a good aesthetic form, and also due to its nice color of the light that it produces. And an application of that is the restaurants, and for that we will use the filament lamps and the restaurants as you see here, so it gives a beauty shape or a beauty decorative shape. Also, the second application of the filament lamp is that it gives a higher CRI that achieved from the light output of it, so we will use it in the gold stores as we need a higher CRI to express the gold on its original color. So we will use the filament lamp due to its higher CRI at that application. And also we use it in the clothes shop as we need the clothes to appear in its original color. And finally, the third application of the filament lamp is that we need it to control the light output of it, so for that we use it in the convention halls. As in some cases we need to reduce the light output of it, and in some other cases we need to increase the light output of it. And this is done as we said before using the dimmer circuits. So according to the convention hall's nature, we can decrease the light output of the filament lamp or we can increase it. More than great. Now the last thing we need to understand in this tutorial is the different types of the filament lamps. As the filament lamps has some different types, so they are the incandescent lamp, and it's the most popular one, and this is its shape here. And the second type is the carbon filament lamps, and this is its shape, so it's nearer in its shape to the incandescent lamp, while it differs in the shape of the filament that is used inside it. And finally we have the halogen lamps, so it differs in its shape a little bit from the incandescent lamp and from the carbon lamps, and it's smaller in its size from them. And we use it frequently in the chandeliers due to its beauty decoration shape that looks like that shape here. Very good. So that's about this tutorial, and on the next tutorial we will extend talking about the different types of the lamps that are used in the interior and the exterior design. Hope that's clear right now. Thank you for watching and see you next tutorial. Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will continue talking about the different types of the lamps. So fasten your belt and let's get started. The aim of this tutorial is to learn about the second category of the lamps we have, which is the gas discharge lamps. So we need to know what are the gas discharge lamps and how they work and what are their different categories in details. So let's go ahead. First of all, if we need to know what is the basic idea behind the gas discharge lamp, we say that it's a lamp that contains a certain gas inside it, like the neon gas. And the job of this gas is that it gains an amount of energy that makes it moves inside the lamp and collides with each other, and those collisions between the gas particles makes the lamps to emit a light out of it, like that lamp here. It contains a neon gas inside it, and when there is an electric power source that is applied to the lamp terminals, there will be a voltage applied through the lamp. So this voltage will give the neon gas particles a great amount of energy, and this energy will make the neon gas particles to accelerate and move inside the lamp. And as a result, the gas particles will collide with each other as it gains an amount of energy, and also they collide with the lamp glass. And as a result of those collisions, the lamp will start to bright or emit the light out of it. So that's for the idea behind the gas discharge lamps, which gives a light out of it due to the discharging of the gas particles inside the lamp itself when it gains an amount of energy due to the voltage applied to it. Alright. Now, if we need to know what are the subcategories of this lamp, we say that under the gas discharge lamp category, we have four main types. And those types are the fluorescent lamp, which is this one here, and the mercury vapor lamp, which is that one. And also we have the sodium vapor lamp, which is that one, as this is its physical shape. And finally we have the metal halide lamp, which is that one. So those are the four categories which represent the gas discharge lamps. But we need to analyze each one of those types in some details to know their different features and why we need to use them. So let's start with the first type, which is the fluorescent lamp. Here, this is the most common shape of the fluorescent lamp, which is that long tube here, or that white long tube. And if we need to know what are the different properties of the fluorescent lamp, we say that the fluorescent lamp consumes a lower power to produce the same amount of lumens, and this means that it doesn't consume much power to get the required amount of lumens, and this is if we compare it with the filament lamp. So for the same light out of the two lamps, we find the fluorescent lamp to consume less power than the filament lamp, and this means that the fluorescent lamp is an economic one as it consumes less electric power, hence it costs less money. And the second property of the fluorescent lamp is that it has lower losses, which means that the power losses of the fluorescent lamp is low, so it has lower heat losses and lower losses in electricity. And the third property of the fluorescent lamp is that it has a larger amount of lumens out of it, so the light out of it or the lumens out of it is high. And finally, it has a higher, longer lifetime, so the number of working hours of the fluorescent lamp is high, or it lasts more before being damaged or burned out. Very good. But the important property of the fluorescent lamp is that it's not recommended to be used on a height that is larger than 5 meters, and this is because the light density of the fluorescent lamp decreases greatly if we use it at a height that is larger than 5 meters. So for the maximum height of the fluorescent lamp, it's 5 meters from the working plane to get the strong light density, or for the light density on the working plane not to be a weak one. But you can ask now, how can we use the fluorescent lamp if the height of the place we are working on is higher than 5 meters? So if the ceiling of the room now is on a height that may be 10 meters or 15 meters, like what is in the malls or on the big areas, how can we use the fluorescent lamps on those applications like the malls, knowing that the fluorescent lamps is not installed or is not recommended to be installed on a height that is larger than 5 meters? Here at that case we have a solution, which is to install the fluorescent lamp on the walls of the space, so we can use the wall mounting method, as at that case we can put the lamps on a height which is less than 5 meters, as we are not related to the ceiling at that case, but we put them on the walls. So if we have a space like that one, we can use 4 fluorescent lamps, one on each wall. But the problem or the disadvantage of installing the lamps on the walls is that the lumens will be concentrated on the edges of the space, while there will be a lower light or lower amount of lumens on the center. So the center of the room will not have a sufficient amount of light, and this is a result of installing the lamps on the walls, not on the center of the ceiling. And as a result, we will have a bad distribution of the lux on the different parts of the room. And to solve this problem, we use another method of installation of the fluorescent lamp, which is the hanging method. And by that method, we install the lamps using some wires that are coming down from the ceiling, then they are tied with the lamps, like that case here, so they are hanged on the ceiling down to the lamp. And we use this method to overcome the larger lengths of the ceiling. So suppose the total height of the floor is 12 meters. At that case, we cannot install the fluorescent lamp directly on the ceiling. So we go down with some wires that have a length of 8 meters. And at that position, the lamp will be hanged to have a height of 4 meters only from the ground. So we are now on the available limit of the height not to be larger than 5 meters to conserve the required density of the lumens on the working plane. So that's for the hanging process, which is the second solution. Now the last solution is to use the suspended ceiling, and the suspended ceiling is an additional ceiling which is not the concrete ceiling, and it's constructed under the concrete ceiling like that one here, and this suspended ceiling is used to install the luminaires or the lamps on it at the required length from the main ceiling. So suppose the main concrete ceiling has a height of 12 meters. In that case, we can construct the concrete ceiling on a height of 8 meters only from the main ceiling, so the lamps will be installed on 4 meters from the working plane. And by that way, we managed to get the ceiling down much more for the lamps to be installed on the required height to get the required lux out of the lamps. So we say that the suspended ceiling is a ceiling that lays under the main concrete ceiling used to install the lamps and the other electrical and mechanical devices on it. Very good. So that's about the fluorescent lamp, and on the next tutorial we will continue talking about it to know what are the different types of the fluorescent lamps. Hope that's clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue discussing the different types of the lamps. So fasten your belt and let's get started. The aim of this tutorial is to learn about the different types of the fluorescent lamps and the different properties of each type of them. So let's go ahead. If you remember, on the previous tutorial we started talking about the gas discharge lamps, and we illustrated the first type of the gas discharge lamps, which was the fluorescent lamp, to know the different properties of the fluorescent lamp. And now this is the time to illustrate what are the different types of the fluorescent lamp, as the fluorescent lamps are not one type or they have not one shape. So the first type of the fluorescent lamp is called the compact fluorescent lamp, and this is the shape of the compact fluorescent lamp as you see. But this compact fluorescent lamp has a great disadvantage, which is that it has an electronic circuit which produces harmonics of the voltage sine wave. So for the input power supply which will feed the compact fluorescent lamp, its voltage waveform will be changed from the original pure sine wave to the waveform which has some harmonics. And the harmonics represents a distortion in the pure voltage sine wave to be distorted like that blue one here. As you see, it has an irregular shape instead of the pure regular shape, and this is what's called the harmonics. And as we said, the harmonics and the voltage waveform is generated due to some loads like the compact fluorescent lamp, which have an electronic circuit which produces those harmonics to distort the pure sine wave. And as the harmonics harms the power source badly, or it makes the power system to be an unstable one, so we don't recommend using the compact fluorescent lamps due to the instability which it produces. So that's for the first type, which is the compact fluorescent lamp. Now the second type we have is the tubular fluorescent lamp, and this tubular fluorescent lamp has two types under it. The first type is called the TLD, and the second type is called the TL5. And there are some differences between the two types or the two lamps. So the first difference lays in the physical shape, as the TL5 lamp has a diameter of 60 mm, so it's a tube that has a diameter of 60 mm. While for the TLD it's much larger, or it has a much larger diameter to be 26 mm, so it's very obvious that the TLD diameter is larger than the TL5 by 10 mm, or the TLD is much wider than the TL5 by 10 mm. Then for each type of the two lamps, they have three sizes. The first one is the 60 cm, and for the TL5 lamp, this size corresponds to a value of wattage of 14 watt, and it produces 1200 lumens. So the 60 cm has an input power of 14 watt, and its output lumen is 1200 lumens. So that's for the TL5. While for the TLD, For the same size 16 centimeter, it has an input power of 18 watts and it produces an output lumens of 1350 lumen. So the TLD has a larger input power of 18 watts while the TL5 has a smaller input power of 14 watts. But the TLD produces a larger lumens of 1350 lumens while the TL5 produces less lumens of 1200 lumens. After that, the second size we have is 120 centimeter in length, and this size has an input power of 28 watts for the TL5 type, and it produces lumens out of it of 3000 lumens. But on the other hand, for the TLD type, its input power is 36 watts, and its lumens out of it of 3200 lumens. Very good. Now the third size we have is the 150 centimeter and its input power equals 35 watts and it produces 5000 lumens for the TL5 type. But on the other hand, for the TLD type, it has an input power of 58 watts and produces an output lumens of 5400 lumens. So it's very obvious that the TLD type consumes a larger input power than the TL5. Alright, but the important question now is that which one is more efficient or which one has a larger efficiency? Is it the TLD or the TL5? Here to know, we can take an example on a size of the three sizes to compare the efficacy between each of them. So we can take the 120 centimeter as an example, and now for the TL5 type, its efficacy equals the lumens out of it over the input power, so it's equal 3000 over 28, which gives an efficacy of 107. But on the other hand, for the TLD efficacy, it's 3200 over 36, which gives an efficacy of 88. So 88 of the TLD is less than the 107 of the TL5, which means that the TL5 is more efficient than the TLD. So we can conclude that the TL5 is more efficient than the TLD, or it has a higher efficacy than the TLD. And due to the larger efficacy of the TL5 type, it's used much more than the TLD, or the TLD is less popular and the TL5 is the much popular one in the lighting applications. And for the lifetime, it's larger for the TL5 to be 30,000 hours. But for the TLD, its lifetime is only 10,000 hours. So the TL5 lamp lasts much more as its lifetime is 3 times larger than the TLD. And from all of those points, we can conclude that the TL5 lamp is better than the TLD, and for that reason, it's more expensive. So the TL5 lamp is more expensive than the TLD. Very good. So that's for the different types of the fluorescent lamps. Now the last important thing to know is that how the fluorescent lamp can be connected. So we need to know what is the electrical diagram of the fluorescent lamp or how it works. Here we say that we have two ways for connecting the fluorescent lamp or for the fluorescent lamp wiring. The first one is the old method, and at that method we use an element that is called the magnetic choke coil, and we use another that is called the starter. And the wiring diagram of this method is that the choke coil is connected to the power supply from one terminal, and the other terminal of the choke coil is connected to one side of the lamp, and then the other terminal of the other side of the lamp is connected to the other component, which is called the starter, and the other terminal of the starter is connected to one side of the lamp on the other terminal, and then the same side of the lamp of the second terminal is connected to the other terminal of the power supply. So at that method we have three elements: the lamp and the choke coil and the starter. And the job of the choke coil is to decrease the current that is passing through it, and this is to increase the voltage applied to the lamp. So when increasing the voltage applied to the lamp, this gives the gas inside the lamp the required energy to be discharged and to produce the light out of the lamp. As we know, the current equals the voltage over the resistance, so when the current decreases using the choke coil, the voltage will increase to the required level. So that's the job of the choke coil. Now for the starter job, it looks like a capacitor which makes a continuous operation of opening and shorting the circuit. and the shorting means that the two terminals will be connected to each other, and the opening means that the two terminals will be disconnected from each other. And this continuous operation of opening and shorting the two terminals using the starter is done only at the starting operation of the lamp, but after the lamp starts to bright and after the starting operation, the job of the starter will end and we can remove the starter from the circuit at that case, as it will not affect the operation of the circuit. So the starter is used for the starting operation only at each starting operation or at each time we energize the lamp. So that's for the first method of wiring the fluorescent lamp. But the magnetic choke coil of this method has some properties, which is that it has a lower power factor, which is about 0.4 or 0.5, so it's very low power factor, and due to this low power factor it consumes a larger power, and also it has a larger lifetime. So it has a higher lifetime, which is an advantage, but it has lower power factor and this is a disadvantage. Now the second method of connection is done using the electronic choke coil, and the electronic choke coil has an electronic circuit that does the job of the magnetic choke coil and the starter at one time. So we replace the magnetic choke coil and the starter by the electronic choke coil. So we replace the magnetic choke coil by that electronic choke coil and we need no starter. And this electronic choke coil has 6 terminals. 2 for the inputs that are connected to the power supply and 4 for the outputs that are connected to the lamp. So 2 are connected to one side of the lamp and the other 2 are connected to the other side of the lamp. And this electronic choke coil has a higher power factor than the magnetic choke coil. So its power factor ranges from 0.8 to 0.85. And for that reason, the electronic ballast or the electronic choke coil has a lower power consumed, so it consumes lower power, but its disadvantage is that its lifetime is low, so it has a lower lifetime. So that's for the fluorescent lamp different configuration. More than great. So that's about this tutorial at which we continue talking about the different types of the fluorescent lamps. Hope that's it clear right now. Thank you for watching and see you next tutorials. Hello and welcome everyone, very happy that we are all together again. In this tutorial we will continue talking about the different types of the lamps. So fasten your belt and let's get started. The aim of this tutorial is to learn about the other types of the lamps we have, like the sodium vapor lamp or the mercury lamp and the lead lamp and so on. So we will analyze their different properties to understand each of them well and to know later which lamp will be suitable for each application. So let's go ahead. If you remember, we talked previously about the compact fluorescent lamp, and now we need to talk about it in some details. Here, the first advantage of the compact fluorescent lamp is that it's a compact lamp, and this is as it has a spherical shape of the glass, so this spherical shape makes it to consume a smaller volume, and this is with respect to the tubular fluorescent lamp. So the tubular fluorescent lamp is reduced when we are using the compact fluorescent lamp, so the reduced volume is an advantage of the compact fluorescent lamp. Very good. But this compact fluorescent lamp has 2 types under it. The first one is called the integrated compact fluorescent, and at that type the glass of the lamp and the electronic circuit are integrated in one package, so we cannot split the lamp glass from its electronic circuit, as both of them represents one part. So it's one part lamp, and also this integrated compact fluorescent lamp is the most popular one, and this is because the lamp parts are integrated in one fixed package. But the disadvantage of this lamp is that if any part of the lamp is damaged, it will be replaced totally. This is because it's one fixed part, so if the glass is broken, its electronic circuit will not be useful. And if the electronic circuit is burned out, we cannot use the glass because the 2 parts are attached to each other permanently. And this advantage of paying one fixed part makes its cost to be less, so its cost is not high due to paying one part only. Alright. Now the second type of the compact fluorescent lamp is the non-integrated compact fluorescent, and at that type the lamp consists of two parts that we can attach with each other or we can separate from each other. So the first part is the lamp glass and the second part is the lamp plug. So they are two parts, and this type is the less popular one. So the non-integrated compact fluorescent lamp is less popular than the integrated compact fluorescent, but its advantage is that if one part is damaged, it can be replaced. So we will not lose all of the lamp, as if its glass is damaged, we can replace it and use the same glass. And for that reason it costs much higher, so the non-integrated compact fluorescent lamp is more expensive than the integrated compact fluorescent lamp. Very good. Now the next type of the fluorescent lamps we have is the circular fluorescent lamp, and this type has a decorative shape as it has a circular shape. And this type has three types under it. The first one is T5, the second one is T6, and the third one is T9. So each of them has a specific amount of the output lumens, and we can detect the suitable one for its suitable application from the datasheet of the lamp according to the output lumens and the distribution of the lux on the working plane. Alright. Now the third type we have is the sodium vapor lamp, and this type of its name has a sodium gas inside it. So the sodium is the gas which is discharged to get the required energy to produce the required output light. And this type has a yellow output color, so the sodium lamp produces a yellow color. But this yellow color is not comfortable for the eyes, so this is a disadvantage of the sodium lamps, as its yellow color light is not a comfortable one. And also we have some standard ranges of the power that this lamp is manufactured with. So if we need to buy a sodium vapor lamp, we will find those values of the electrical power to exist in the market. Here its power standard values is 70 watt, 150 watt, 250 watt, 400 watts, 600 watts, 1000 watts, and 2000 watts. So those are the standard ranges for manufacturing the sodium vapor lamps. But the sodium vapor lamps has two subcategories under it, and those subcategories are the low pressure sodium and the high pressure sodium. And the difference between them is that for the low pressure sodium, the gas inside the lamp has a low pressure, which means that the gas is discharged under a lower pressure, and as a result, the gas will gain a low energy, or the gas atoms will have a low level of excitation, so they collide with each other with a less value of energy. And as a result, the output light will be low, or the lamp will produce lower lumens. As for the high pressure sodium lamps, its gas is discharged under high pressure, hence the gas will gain a high energy, and the gas atoms will collide with each other at a high level of excitation, and as a result the gas will produce a larger value of lumens. So we can conclude that for the same input power for the high pressure sodium lamps, they produce a larger amount of lumens than the low pressure sodium lamps, and as a result the lamp will produce a larger value of lumens. So we can conclude that for the same input power for the high pressure sodium lamps, they produce larger amount of lumens than the low pressure sodium lamps. For example, if we have two sodium lamps, one is a high pressure sodium and the other one is a low pressure sodium, and if the input power of the two lamps is the same of 150 watts, at that case we find for the high pressure sodium lamps it produces an output lumens of 28,050 lumens, while for the low pressure sodium it produces only 22,000 lumens. So it's very obvious that for the same power, the high pressure sodium lamp produces a larger value of lumens than the low pressure sodium lamp. Very good. Also, the next type of lamps we have is the mercury lamp, and in that case we are using the mercury as the gas which is discharged to produce the output light. And this type of lamps has a white output color, so it produces a white color. And for that reason its output color is a comfortable one for the E, as the white color is comfortable, unlike the yellow color for the sodium lamps which were a non-comfortable one. And for its output lumens, it produces less lumens than the sodium lamps. And finally, for its manufacturing power ranges, it has the same manufacturing power ranges of 70, 150, 220 until the 2000 watts. So it has the same power ranges of the sodium lamps. Alright. And by the same way, this mercury vapor lamp has the same two types, the low pressure mercury and the high pressure mercury. And for the high pressure, it has the highest excitation of the gas, hence the highest output lumens, while for the low pressure mercury, it has a lower excitation of the gas, hence a lower output lumens. Very good. Now the next type of the lamps we have is the metal halide lamp. And this type of lamps has a white output color, so it produces a white color, and for that reason its output color is comfortable for the ease, as the white color is comfortable, as we said, unlike the yellow color. And it has an output lumens which is larger than the sodium lamps, so it has the largest output lumens. So we say that the metal halide lamps produce the largest output light. And for its power ranges, it has the same power ranges on the market that we have said before. Alright. Now the last type of the lamps we have is the LED lamps, and the LED is the abbreviation of the lighting emitting diode. And the basic idea behind the LEDs or the light emitting diodes is that it's a semiconductor which has a diode, and this diode will allow the current to move in a certain direction while it doesn't allow it to move in the inverse direction. So for the semiconductor diode, the current is moving in one direction only. And for the LED, it's not a normal diode, but it's a light emitting diode which produces a light when the current passes through it. And for that, it's called the light emitting diode, which produces a light when the current passes through it. But this is the basic LED. And for the LED lamps which are used in the lighting designs, it looks like that shape on the upper here, which have many integrated LEDs on it. And some of those LED lamps are working on the AC power, and some others are working on the DC power. And the best advantage of the LED lamps is that they are energy saving lamps, so they save about 50 till 80% of the input power, and this means that the LED lamps have less losses with respect to the other types of the lamps, so they are saving the electricity with higher ranges. And also the second advantage of the LED lamps is that it's a safe technology, so it doesn't harm the environment or it doesn't pollute the environment. And this is because it doesn't contain some gases to be discharged, but its working principle depends on the light emitting diodes. And for that reason, it doesn't contain any toxic gases which may harm the environment or the people if they smell those gases. Very good. But the disadvantage of the LED lamps is that it has a higher fixed cost, so when you buy a LED lamp, you find its price to be larger than the other types of the lamps, and this is the fixed cost. But for the running cost, the LED lamps have a higher running cost, and this is because the LED lamps needs less maintenance, and as a result we find the LED lamps to be the best solution as it consumes less money at the long term. And also it has the largest lifetime, so the LED lamps have the largest lifetime or the largest number of working hours before being damaged or burning out. And from all of those points we find that the LED lamps are the best solution and they are the newest generation of technologies. More than great. So that's about this tutorial at which we continue talking about the different types of the lamps. Hope that's clear right now. Thank you for watching and see you next tutorials.